This is in the afternoon, but apparently I'm set it to broadcast at midnight, so I've never done that before. So for today, hello, uh, I'm going to be playing with Supercollider and looking at how fractions and scales work and that kind of thing. Because it became it's an interesting way to sort of learn physics and proportionality and how that relates to music. Excuse me. Which is not something that it's not an approach that we often take in education, but I think that that's overlooked because there's an elegance to this proportionality of music. So I booted up Supercollider because I find this a very useful tool for this. So what it is I'm going to have control over various frequencies. It's going to be 110 because 440, and then our proportionalities are there 1 and 2. So that will be 110 and then 220. So that's one whole octave. So that whole octave should, that basically, once you have one octave, then you just double it and you've got the next octave and the next octave. So we just need to really cover one octave and the proportionalities within a single octave. So I've set up this Super Collider because that way also over here we can see what kind of cool shapes maybe stuff makes in those proportionalities. So this is going to be, because of the way to make something look good, you basically need a couple of different frequencies working against each other to create a three-dimensional kind of thing. So here I have just plain old 110 with a slight variation here, 110.01. That's to get a difference between the two sides, the two signals left and right, which will then rotate the sine wave that I'm making. And this PMOC, but this, when you set it at 0, this is called the pulse modulated oscillator. There's a carrier frequency, a secondary frequency. Carrier frequency, secondary frequency. You can set these different, but I like to set them the same usually, or like simple proportions. That's overtones, how many overtones you're going to add to the sound, and then a phase thing and a volume. So here, I'm just going to run a 1. This is going to be a one note continuously playing. Boo, boo, boo. It's going to be really boring sounding. Oh, we can't even hear it because it's so quiet. But here it is. There's a sine wave. And because of that 0, 1, it's slowly rotating in space. Sorry for that. I hope that didn't get you too sick of a feeling when we move fast like that. Okay, so what am I going to do? Let's just, for goofing sake, let's boost this up to 10. Oh, no, that's, yeah, overtone series. So let's see what happens if we get anything special there. And still not, because I don't know why. Actually, I don't understand why. But you'll see, as soon as we make it work with this other oscillator, here, let's make this. I'm going to set this to 1. So we're going to have 2 of them going, both at 1. At the same frequency, only this one's got the 10 overtones and this one doesn't. So I'm going to start this and see what we see. Oh. Now we see those overtones. Yeah, I'm going to set it over here to 100. Again, I think that's so many, I can't even handle it. Notice it's got like squares, because it can't find all the points in between. I know, so cool already, right? See, this is what's hiding underneath. So these are just 2 oscillators, only one of the oscillators in a slightly out of phase with each other. but one of them has 100 overtones and the other one has no overtones at all. Pretty crazy, but that's not what we were focusing on today. As cool as that is, because I'm sure we'll get some nice pictures. Oops. There we go. Okay, so let's just do this again. And these are two oscillators, and both at 0 overtones, just to make them as simple as possible. There we go. There's two exactly identical oscillators. So therefore they just make this one very simple thing. Now what we're going to do is up on the top one, we're going to add 2. So we're going to switch between the two notes, 1 and 2, which would be 1 in the double. Now see, oh, 1 double, 1 double, 1 2, 1 2 loops, 1 loop, 2 loops. Okay, that's pretty simple. That's an octave. So now let's put the 1.5, because that's what's in between 1 and 2, as I recall last time I looked. So let's see what happens now. One and a half, 2, 1, 1 and a half, 2, 1, 1 and a half, 2. Because 1 and a half is kind of like 3. You know, it's 3 halves. That's gonna add some, I'm gonna add some overtones so we can hear that what the heck's going on, because it's just, sine waves are so pure. Oops. You can't hear them. Where do I have my volume set down? No. Okay. Why are we not hearing anything is partially what I'm wondering. There we go. Wasn't loud enough. Okay, so let's set these both the same again. One is playing 110 all the time. One is going to play 110, 1.5 times 110, and twice 110. A little overdriving the speakers there. Knock these down a bit in volume, trying to show that as I go. Okay, I am going to hit both of these with a ×2. Just because that will put it more in an audible range. It's brutal, isn't it? Oh yeah, I gotta learn not to move my hand at all. Okay, so now we're going to do 1 1/4, 1 1/2, 1 3/4, 7, and 2. I'm going to stop and do this. So this is now 1, 1.25, 1.5, 1.752. See, that's pretty harmonic. That's almost the scale right there. Let's add. So we did the halves, we did the quarters, we didn't do the thirds. So let's put the thirds in place. So that's going to be 1.33 recurring, we'll call it 1.34. And up here it's going to be 1.66 recurring, which we'll call 1.67. And now let's see how that scale looks, sounds like, and looks like. There we go. See? All math. And that wobbling is because I didn't do 66666 recurring. I'm going to go over here and do that just to prove it's true. 6, a bunch of 6s. Just nobody wants to do that, right? You can't do it. I mean, I can do proportions, but I wanted people to see the numbers. So, we'll do. I know, sacred geometry, right? It's just physics. It's all the same. I mean, it's just physics. Nature. So beautiful. Okay, so let's see. We got the, we did the halves, the quarters, the thirds, the halves, the thirds, the quarters. We didn't do the fifths. So that would make this 1.2. Wait. I'm going to rest you for a second. There we are. Anybody that's foolish enough to be watching. Okay. So that's 1.1, 1.2, 1.4. So we've got too many things. 4.6. 1.8. And 2. Okay, so now we got kind of too many letters. 1.2. So now we've done the fractions up to the fifths. And let's play these. Let's see what they look like against each other. And again. Now we've almost got a chromatic scale going. I think the 6s get really weird, but if you add the 8s, 1.125, 1 point, yeah, forget it. It's going to be like 2.5, 3.25, 3.3, that's too close. Not even worth doing. Then it would be 1.5, then 1.625, which we already got 6. That's a little crowded. 7.5, and then 8.25. Let's throw that in just for something's sake. Let's see if we can even hear the difference at this point. It's getting to be too many notes. We only need a few. Oh wait, sorry. This isn't too tight, but I'll show you the scale that I usually use, or a couple of scales that I usually use. Oof. Which is 1, 1.25, 1.2. Let's get to the 1.25 because we already got the 1.2. 1.34, 1.5. 1.6 or 1.66. That's a very, like, I find that's like a very moody thing. It's like whether you want to go minor or major. 7.5 is too close, so let's go for the 8. And then the 2. It's like a minor scale. See? Look at that. It's all in there. So much. This is why I really think that like music and the relationship between mathematics and music should really be much more exploited in education than it is. Because that's what resonance is all about, right? It's like those harmonics, it's the series, it's how things relate to each other. It's like moduli and how moduli interlink with each other. That is what harmony is. It's like having a common denominator is harmony. Oh my God, I'm about to put that up on Twitter, I think. But that's true. The more common denominators you have, the more in harmony you are. 2 prime numbers don't have anything in common with each other, right? Primes don't have anything in common with hardly anybody. The cool thing is that primes also sort of start their whole own universes off, so I don't know. That's the way it is. Okay, so I don't know. This was an interesting thing. This is a 20-minute long. If anybody has any feedback ever, please. Yeah, I'd love to help understand or help anybody understand anything if they don't with what I'm talking about. So, have a beautiful day and later.